Good afternoon. Once again, it is 2:01 p.m. on Thursday, October 29th, 2020. This is Computer Science 156 from UC Santa Barbara. I'm your instructor, Phil Conrad. Our topic for today is interfaces, comparators, sorting, Lambda expressions. Last time we were looking at this code for the student class. Let me bring up this code for the student class here. Let's go right to the student class. And what we did last time was we added implements comparable student to this class. This is a way that we can build, but by implementing comparable student, this is a way that we can build into a class one single way of comparing objects that could be the basis of a sort. The limitation of comparable is that you can only have one implementation of comparable per class, whereas comparators, we can have an unlimited number of ways of comparing objects of a particular class. But it's convenient to associate one way of comparing directly with a class. Java calls this the natural ordering of the class. We should say that natural ordering is a term of art here. There's nothing natural about ordering students by perm number as compared to ordering them by name or ordering them by GPA or ordering them by zip code or whatever. It's just the word we use for the order that is defined using the comparable interface. Java calls that, the Java ecosystem calls that the natural order for the class. So how do we implement comparable? Well, implementing an interface in Java means if you go and you look up that interface, comparable student, and so let's just go to our handy dandy internet search here and do Java comparable, and I like to put in 11 for the version of Java so we get the right version. Here's the comparable interface in Java version 11. This wall of text, we scroll past it. That's just as a reminder, these are all of the known classes that implement comparable, and it's lots and lots of them. We see that there is one method in the comparable interface. It is the compare to method. That's the method we have to implement. So when you see at the top of a class, public class whatever implements some interface, in this case comparable, read that as implements each and every method of comparable. Unlike inheritance, when you say public class student extends human, for example, inheritance is when you get something from the base class. Just like if you inherit property from your grandfather or your grandmother, that means you are getting something from them. But that's inheritance. You get something from the class that you inherit from. You don't get anything with implementing except an obligation. When you implement an interface, you take on the obligation to implement the methods of that interface. In this particular case, there is one and only one method, compare to. That is important. What we're going to discover in the course of today's lecture is that when an interface has one and only one abstract method, then it can be designated as a special kind of interface, a so-called functional interface. And functional interfaces are special because we can use Lambda expressions for them. But I'm getting ahead of myself. We will come back to that idea later. For now, just know that when you implement an interface, there is one and only you have an obligation to implement each and every interface of that method. With comparable, there's only one interface, compare to. We implemented that right up here at the top, and we implemented it by taking the perm of this object, subtracting the perm of the other object. O, in this case, stands for other, the other object, or might stand for object, but I think it stands for other, the other object that we're comparing against. So there is some student, and as you can see here in the code, I have this comment. You would use this if you have student S1 and S2 by making a call S1.compare to S2. And if these two have the same perm, this should return 0. If this perm is less than, S1's perm is less than S2, this should return a negative number. If S1's perm is greater than S2, it should return a positive number. And this expression, simply subtracting them, does that. I will mention there's another way we could have written this, and this is the way you see it more often. There is a function, there's a method of the integer class called compare, and you can pass in two perms. So I could have passed in this dot perm and o dot perm to the integer.compare method, and I would get the same result. Now, whether it actually is implemented by this subtraction, we don't know and we don't care. The only thing that we care about is whether the return value is negative, 0, or positive. And this integer.compare does exactly that. In fact, as the VS Code very handily pops up the Java doc for it, you can see the parameters as it says here. X and Y are the first int to compare, and the second int to compare, and it returns the value 0 if X is double equal to Y, value less than 0 if X is less than Y, value greater than 0 if X is greater than Y. That's what all of this says right here. I'm going to take this back out, or maybe I'll just leave it there. And I'm just going to take it back out because I don't want to have to do another commit for this branch. So that's compare to. With that compare to method implemented, then implements comparable is satisfied, which means then that over here in in read students, we are able to use collections.sort, pass in this array list, and it will sort it based on the order we defined. So you can use collections.sort and just pass in an array list, and it will sort it according to the natural order. That is the order defined if this class implements comparable. Now, let me just quickly show you. I think we're on this branch. If I do Maven package and then run this class, as a reminder, we're going to run it with Java -cp target student. Then we give the full package name of the class, edu ucsb cs156.student, student, hard to spell when it wraps around, student dot read students. We're passing in the name of a data file, in this case, data more data.csv. And we get these two lists of students. Actually, I think we took it one list of students. So I think we just printed it out one time. After sorting it, and it should be sorted by perm number. And indeed, there's all 2s, all 3s, 999, 996, all 9s, and then a bunch of 1s, and then 1, 2, 3, 4. Okay, so they're sorted in increasing order by perm. Now, if I were to go into my student class, and if I were to comment out this implements comparable student, even if I leave the compare to method in, if I don't have, in fact, rather than commenting it out, let me just remove it completely. Knowing that in VS Code, we can always go back to the way that it was before just by clicking on this little blue bar and hitting the little hook here. That little hook is, move the zoom window out of, come on, zoom window, move out of the way. This little hook right here, this little one right here will restore it. But then if I say, no, I really want that to go away, I'll take it out again. All right, take that out. What will happen if I try to compile the code? Well, the student class will be just fine. There's no syntax error here in the student class. But read students. Notice the wavy line. VS Code already knows before I even try to compile that the method sort doesn't work on students. And why not? It says, if I can move my zoom controls out of the way here and get this, all right, okay. All right, it starts and then the method, okay, there, I'm trying to get that message before it changes. VS Code, cooperate with me, darn it. All right, it doesn't, I can't get that message to stay. So we will just get the message that comes up when we try to compile. So we're going to try to compile again with Maven package and see what error message we get. So the error message we get is way back up before all this test stuff. Let's get the compiler message. We should get a compiler message. Come on, it went too far. Darn it. All right, let's try instead clear, Maven, clean, compile. Okay, there it is. Method Java util collections T sort on Java util list T is not applicable. Inference variable T has incompatible bounds. The lower bound is Java lang comparable question mark super T method Java util collections T sort blah blah blah. This is a very long-winded way. And as when we get to the reading assignment for chapter 16 in Head First Java, you will have a complete explanation of this with cartoons. This very confusing error message, what it's really saying is students doesn't implement comparable. As a result, this is not something that can be passed into collections.sort. So if you want to use collections.sort, you have to implement comparable, and we will see that. Not just that you have to implement comparable, meaning you have to have a compare to method, you have to actually declare up here in the class heading that you implement comparable. So we'll bring that back, and we'll see that just bringing back that little bit right there will make this compile. Okay, so that is a review of what we went over last time. Now, let's take it the next step. This allows us in our read students to compare on the basis of one thing, which is it allows us to compare on the basis of the perm number. But suppose we wanted to sort our students by, let's say, their name. What could we do? Would we have to go into our student class and modify the compare to method to sort by name and not by perm? Would we have to modify our code every time we want to sort by something different? That doesn't sound like a good idea. So there's got to be another way, and it turns out there is. So I'm going to check. First of all, let me do a get status, make sure I have nothing left over here. My working tree is clean. So I'm going to get checkout ex15. And I'm going to show you that we now have we're now still back in readstudents.java. This is the new version. And I've changed things up a little bit. Instead of just using system out println students, I have made a list students method. It takes a list students. Now, again, notice here, my actual parameter students is of type ArrayList student. My parameter here is list student. And the reason this works is because ArrayList student implements list student. It's not correct to say that ArrayList is a list. It's correct to say that ArrayList implements list. Since ArrayList implements list, any variable that is of type ArrayList can be passed as a parameter to list. List is an interface, not a class. It's a list of methods. Well, that's what an interface is. As long as this reference here is a type that declares that it implements all of those methods and does in fact implement all those methods, then I can pass students in as a parameter to list student. I would also be able to pass things into this method that are not array lists, but are vectors, queues, stacks, anything that implements the list interface. So list is more general than array list, but it's important to understand it's an interface, not a class. So array list does not inherit from list. Array list implements list. If this is confusing, you can read more about this in your Head First Java book. There is a chapter that talks about interfaces. I think it's chapter 7 or 8 or 9. And then you can also read about list and array list specifically in chapter 16. In any case, once I have this list of students, I can use this special kind of for loop in Java for student s : students. That basically says, I'm just going to iterate through this list, and however many students are in this list, that's how many times I'm going through this for loop. For each one, I will print it out. The difference between this and just doing system.out.println students is that if I do this, they're all going to come out on one big line. This, because it's print line, will put each one on a separate line. So that's the one change. The second change is this. I first of all print out all the students in the order that they're in the file. We read them in from the file. We just print them out in that order. Then I use the collections.sort with students. That's the natural ordering where we sort by perm, and I print them out. Then I use this new thing, which is a student name comparator. So that's the first new concept we've seen in today's lecture. Everything up till now has been basically review. This student name comparator is a class, and here is the code for that class. We're going to look at it in a minute. Well, we're looking at it right now. You can see it's very, very short. We'll come back to that in a second. What I'm doing here is creating a new instance of that class, and I can pass that new instance to students.sort, and I will sort based on the criteria that this comparator defines. So what is a comparator? Well, let's take a look. Here's an example of a comparator. A comparator is anything that implements the comparator interface. Comparator is a parameterized interface. It takes a type as its parameter. So you don't have a generic comparator. You have comparator student or comparator course or comparator dog or comparator animal. You pass, you specify which class this is a comparator for. And then there is one method that you have to implement. It's called compare. And it's very similar to the compare to method, except the compare to method that we implemented here takes one parameter and it compares it to the this object. You implement it like this, s1.compare to s2. That's the compare to method. By contrast, the compare method takes two separate parameters and it does the same thing as compare to. It returns an integer that's either less than 0, equal to 0, or greater than 0. So now a question to all of you that are attending the lecture synchronously. This should remind you of something from your CS 16, 24, 32 days, or whenever you took a course in C or C++. There is some function. In this case, it's a function, not a method. There is some function that you call in C and C++ programming that also compares things and returns a value that's less than 0, equal to 0, or greater than 0 on the basis of comparing two things. Can anybody tell me what is the name of that function that I'm thinking of from C and C++ programming? Similar to the blah function from C, C++ programming. So I'm watching the chat to see if anyone comes up with it. And okay, so I see string : compare is one. So string : compare is one answer, and that might be right. But the other one that was suggested is the one that I was thinking of. It's the strcomp function that is used when comparing C strings. So the other answer that was suggested, string : compare, that might also be a correct answer. Off the top of my head, I don't know. But we'll look at that later. Strcomp is the one I was thinking of. So, so this is similar in nature. Basically, if S1 is less than S2 by whatever ordering we're defining, we should return a negative number. And it turns out there is a compare to method built into the string class. s1.getName returns a string. I can then use compare2 s2.getName, and that's how I implement this. So this is my name comparator, and over here in read students, I can simply pass a new instance of that comparator into students.sort, and it will sort by name. So let's see if that works. Let's do a Maven clean, and then a Maven package. And then we will run with Java minus CP target student. There's the jar file, the full name of my class, edu ucsb cs156.student.read students, data, more data. And let's see, here's the order from the file. Sorted by perm, yep, it looks like those are indeed sorted by perm. And it's a lot easier to see now they're all on separate lines. And by name, we have A, C, L, N, N, N. And within the N's, I comes first. Number 3, TH comes before number T, TW. Looks like that works just fine. So that's good. And I think that's reasonably straightforward. And here is the student name comparator. This time I wrote my comparator as a separate class in a file all by itself and gave it a name, student name comparator, as a class. When I used it, I made a new instance of the class by doing new student name comparator. And that's fine, and that works. And this is almost never the way people do comparators since Java 8. So this is the old school way of doing comparators. Why am I showing it to you? Because the way that people do comparators nowadays, the way the cool kids do comparators since Java 8 is with Lambda expressions. But before we can understand what a Lambda expression is, it's probably a good idea to understand what a comparator is in kind of the old-fashioned way of writing Java that we're maybe a little bit more accustomed to. So this, I've got a simple class. It implements an interface. I've got a method from that interface that I'm overriding, and it's straightforward. Now we're going to get a little more complicated. But before we do that, we're running out of things we can compare by. So far, we've compared by perms and we've compared by names. This class has nothing else going on. It's kind of a boring class. Let's make this class a little bit more interesting. So let's see, what have I modified here? I can do a get diff, and it was just adding that one comment. Oh, sure, I'll add that comment. Let's get add dot, get status, get commit minus m, pc, add comment about stir comp. Get push origin, what branch are we on? EX15. All right, let's now check out, get checkout EX16. In this branch, I'm not going to do anything with anything new with comparators. All we're doing in this branch is adding some more interesting things to student. So I've refactored the code a bit. Instead of simply a name, I now have a first name and a last name. Still have perm, but I also have units. That gives us more stuff to sort by. So the changes here are pretty straightforward. I added some more parameters to my constructor. I added some more getters and setters. I changed my toString method. My from CSV, which we went over earlier in the week, now has some extra code to deal with units. I had to modify my tests a bit. I don't have full test coverage at this point, but that's okay. We will come back and fix that up later. Might even leave that as an exercise for all of you. But we have some more things now that we can work with. Let me show that if I do a Maven clean package here. By the way, when you do package, it does run the test. So if the test didn't pass, I wouldn't get a jar file, but the tests do pass. So if let me run this again. I also had to change the data files, by the way, in this, because the data files now have first name, last name, perm, and units. You can see that here I am sorting, this is the order the data is in the file. Here is the perm number order. And then here is in order by last name. One thing to note here is that when we look at last name, I have Gaucho, McNinerson, Sabado, 3, 2, and what? Del Playa? Del Playa shouldn't come at the end. Why is Del Playa coming at the end? I would call this a bug. So who can tell me where should Del Playa come if, okay, exactly right. So the answer came in the chat. It's because of the lowercase ASCII. When you sort strings, we sometimes say, oh, well, strings get sorted in alphabetical order, but that is actually not accurate. They're not sorted in alphabetical order. So I'm just going to put this up on the screen. Not alphabetical, but lexicographic. So lexicographic order is pretty close to alphabetical order, but not exactly. Lexicographic order works on the basis of the order of the character set. So the character set that we're using here, you could say it's ASCII, more properly it's UTF-8. UTF-8 is the sort of the 8-bit subset of Unicode. And it corresponds, the first 255 characters of UTF-8 correspond to the ASCII characters. And in ASCII, the capital letter A is the number 65. And then the lowercase letter a, I think it's 97 off the top of my head. That may be incorrect or correct. But the point is, it's some number that's way bigger than the capital letter A. So A is 65, and then B is 66, and C is 67, etc. And then the lowercase letters start with some number, like maybe it's 97, 98, and 99, and so forth. If those are not exactly the right numbers, it's close enough to get the point across. The point is that the small letter A is lexicographically greater than the capital letter A. And all the punctuation marks fit in here somewhere. The digits are all like 0 through 9 are all less than the capital letter A. So if we want to sort where Del Playa will come in the Ds, what we're going to need to do is convert to lowercase. That is some work that I haven't done yet. We're going to do that live in class today if we get that far, and I think we will. But in any case, for now, we see that this sorting by last name is working properly. What I want to do now is move on to the next branch. So let me do a get status. We're on branch 16. I'm going to get checkout branch EX17. And just as a reminder, all of this code, you can find all of this code if you go to the course website. So UCSB CS156, here's our website. If you click on this part right here, go to tutorials, open up student tutorial. All of these code links are the code for each of these sort of chapters, each of these exercises. We're now on exercise 16 and 17. I haven't put up the pages for those yet, but you can still find the code here if you click on any of these code links. And you can see, if you just click on the branch here, you can select the branch and look at all of this code online. So if you want to come back and review the code later, it's here. And you can also clone the repo in the normal way that we clone repos and work with the code directly that way. And you can see here some of the recent pushes to the branches. So let us go back. We're going to look at branch 17 now. And in branch 17, I'm going to go back to the read students. So we have our natural ordering. We saw that before. We saw the student last name comparator. Now I'm going to show you a student first name comparator. And this is different. So the last comparator we looked at was implemented as a separate standalone class. Here it is, all in a file, all by itself, student last name comparator. The first name comparator, though, as a step towards understanding Lambda functions, I'm going to put this student first name comparator directly inside the student class. And so here is that. Now you see that I am inside the class student. And now I have implemented, we did this before when we defined a couple of custom exception types. We did our invalid CSV line exception, invalid perm exception. This is a class inside a class, public static class, and then we have a class inside a class. Here we have another class inside a class. So this is what we sometimes call an inner class, I-N-N-E-R. Let me just put a comment on here. This is an inner class. It's an inner class because it's a class inside a class. And it's a static class because instances of this class are not associated directly with instances of student. They are independent objects that can live in the world independent of any particular student object. If I didn't put the word static on here, then instances of inner classes have to be sort of joined at the hip to instances of the class that they're inside of, student. So that's why we have the word static here. You can read more about static versus non-static inner classes in your Head First Java book and your Java in a Nutshell 7th edition JN7 textbook. But for right now, just know that we're declaring it static because it's not associated with any specific instance of a student. This inner class looks, except for the fact that it's an inner class, looks a whole lot like that other comparator that we had a moment ago. Trying to see, is there a way to have, I know that I can make two windows side by side. I don't know if there's a way in VS Code to make two windows top and bottom. There probably is. I'll figure out what that is another time. I was hoping to show you that. Well, maybe I can try the side by side view, but it's a little less satisfying because you really can't see the whole thing. But let's give it a try. Here is, where is our student comparator? Here's our student last name comparator. And I'll try to make as much room as I can here on the screen. So you can see that this comparator, public class, student last name comparator, implements comparator student. This one is first name comparator, implements comparator student. And inside, the only real difference is that here, because this one is inside the student class, I don't have to use the getters. Instead of s1.get first, I can just do s1.first. I can do that because this is inside the student class, so I can access private data members directly. But other than that, it's pretty much the same. Oh, I didn't put @override on it. I probably should have. That's just when you implement an interface, it's always a good idea to put the @override on here. That way, in case I, made a mistake, like I did compare instead of compare, VS Code is telling me, but it would also tell me at compile time, hey, dude, you're not overriding the method you think you are. All right, so there is my comparator. It's written as an inner class. Let's go look at read students and see how I'm using that one. So because it's an inner class, I can refer to it by prefixing it with student dot. So anything that's public and static inside the student class, whether it's a method or an inner class, we refer to it by the name of the class dot. So there's my first name comparator. I make a new instance of it. It would not be correct if I didn't have the new here. That would not work. See, I'm getting now it's trying to think that it's a method and it's not a method. So I do need the new in front of that. And we're going to be able to sort by first name. So let's give it a try. Let's just give over to, where's my console window? There it is. Let's Maven clean. Let's Maven package. And then I'm going to use the history command to see when did I run this last. I last ran this here. That was command number 1096. So I'll do bang 1096. And that brings back that exclamation point 1096 brings back the command that was command number 1096 in my history. I got that list by typing history. And that's because I didn't want to hit the up arrow and look for it. And I wanted to not have to type that all again. So that's a useful, handy tip. So you can see that when I ran the program again, I got the original order. I got sorted by perm. I got sorted by last name. And then finally sorted by first name. And then we're going to see a few other things sorted by units. But here's my first name sort. You can see Alex, Chris, Laurel 9, number. So that seems to work just fine. Now, what else do we have here? We now come down here and we see, interesting, a comparator that is declared right here in read students. And it's right here, declared right here inside my main method. So let's review. First, we saw a comparator that was in its own class all by itself. Then we saw a comparator that was inside the student class as an inner class. Now, what is this new sorcery? We have a comparator that's declared right here in line, right in the middle of a method. How do we do that? Well, first of all, we say new comparator student, and this looks like we're invoking a constructor, doesn't it? But we are not. We are not invoking a constructor. And here's how I know we are not invoking a constructor. I mean, we kind of are, but we aren't. Comparator is an interface. And you will read in the textbook that it is not possible to instantiate an interface. And that is true. It is not possible to instantiate an interface. If you've got an interface, you just can't go around saying, oh, new comparator. Except when, if you say new, and this is an interface, and then you provide the entire body of that class inside a set of braces, which is what we've done here. See this open set of brace and that closed brace, and then a closed brace followed by a semicolon, which is something you hardly ever see in Java. We're used to this from C++, but you hardly ever see it in Java. This is like one of the exceptions when you've got a semicolon right after that closed brace. What's happening here is I am defining a new class that implements Comparator on the fly. I've defined a new class, but that class does not have a name. It's a class with no name. It's an anonymous class. It's an anonymous inner class. It's actually an anonymous inner class of read students that happens to be defined on the fly right in the middle of my main method. It doesn't have a name. Now you might say, oh, but professor, the name is units comparator. Nope, that is not the name of the class. That is the name of the reference to the one and only instance of that class that will ever exist. I have created an anonymous class, and at the same moment, I have instantiated it for the one and only time, and then I've made a reference to that class. Now, when I pass that into sort, notice the difference between line 49, where I said new student first name comparator, and line 45, where I said new student list name comparator, and here I just said units comparator. There's no new here because the new already occurred back here on line 56. This is already an instance of comparator, so I can just directly sort with it. There it is. Okay, Now, let me pause here and see if you are still with me or if you have any questions. If you are totally lost, just fess up and say, Professor, totally lost. Go over it again. Or if you have specific questions about what I've talked about so far, ask them. Because the next thing is the toughest leap of faith in this lecture. The next thing, we're going to talk about lambda expressions, and we're going to build on top of the understanding of everything we've done so far. So it's important that we get it. Let me just pause for a moment, and then I'm going to review where we've been one more time before we move on to the lambda expressions. If you're following along and it's all making sense to you, just give me like a thumbs up in the chat, or just like hit the thumbs up in your Zoom window. I would just like to know that this is getting through. This is one of the hard things about remote teaching, is that if you were all in person in a classroom, I could look at your faces and I could just see in your faces that you're getting it and you're nodding and you're with me and your eye contact, or I could see in the dazed and confused looks on your faces that this is making no sense and that I need to go over it again. But in remote teaching, I'm getting nothing. I'm also getting nothing. Okay, so let's see. Good, getting something in the chat. So there are two compare classes, comparable and comparator. Which one is the most used? Okay, great question. And first of all, comparable and comparator are, strictly speaking, not classes. What are they actually? As in contradistinction to classes, I would say that this first name comparator is a class. That's right, they are interfaces. So comparable and comparator are both interfaces. Student last name class is a class that implements comparator. First name comparator is a class that implements comparator. Student is a class that implements comparable. Which one is most often used? It's kind of hard to say. I would say that they're both used a lot. It is typically the case that if you have a class, you will find it useful to define, to make that class implement comparable, because that's the sort of the default way of sorting that object. But then if you want to sort it some other way, that's when you make a comparator. So any other questions? All right, so let's review. We started out by saying that student implements comparable, and we did that by adding this compare to method. Then we made a comparator as a separate class that allows us to sort by a different way from the way that the compare to method inside student sorts. The compare to method inside student is sorting by perm. And we just chose that because we thought most often, how are we going to sort students? Most often we'll sort them by perm. So we'll make that the most convenient sort, the one that we can get with just Java util collection sort blah. But if we want to sort other ways, we can make comparators. The first comparator we made it as a separate standalone class in its own file, which is the normal way that we're used to making classes in Java. Then we did a step where we said, you know what, let's make another comparator, but we're just going to tuck it inside the student class here as an inner class. The nice thing about this is we don't have to make a separate file. It's right here with student, just like the compare to, which is the way we sort by perm, is right here with student. This sorting by first name is right here with student. It's kind of nice and handy. And this still looks pretty much like a normal class declaration in Java. Then we said, all right, you know, we can take this one step further. If I'm in this program and I find that the natural order or these other two comparators already defined isn't what I really want, I can make a new comparator on the fly. So anytime you want a comparator, you can just make one on the fly. And this is the syntax for doing it. And up until Java 8, that is where we left it. But in Java 8, what happened was people said, you know, I'm going to look at all of this syntax. This is super, super duper wordy. I think a lot of this is unnecessary. So let's see what part of this is unnecessary. Well, as soon as I say comparator student, I know that what I'm trying to make is a new comparator. So why do I need to say new comparator student over here as well? That's just wasteful. So goodbye to that. Now, what about this part in here? It says that I'm overriding a method called public int compare, but comparator student only has one method, which is public int compare. Do I need this? I absolutely do not need it. Now, here are my parameters. I've got S1 and S2. Do I need to know that they're both student? I already know that. Oops, that was too much. I already know that they're both of type student. So all I really need to do is give them some names. Then what? Well, I'm returning a value. Well, what else would I be doing? Obviously, that's what I'm doing. So we end up with this. Hopefully I have the right, nope, I need one more parentheses. Boom. And that is how we get to a lambda expression. So the point is, these two lines of code, which I'm going to comment out, the following is equivalent to the code in the declaration above. So what I'm telling you is these 1, 2, 3, 4, 5 lines of code can be replaced with those 2 lines of code. And we can even actually just put this all on one line of code now. And that's it. So the arrow function, okay. So arrow functions were mentioned in the JSPA 01 assignment. I'm glad you mentioned that. So arrow functions are actually a JavaScript thing, and this is a Java thing. They are very similar ideas, but JavaScript and Java implement them a little bit differently. So I'm really glad you brought that up. This is the first time I've taught the course where we did so much with JavaScript, right? We have not, in the past, that was one of the big differences when we went from 56 to 156, was we said, all right, this is upper division now. You all are, you're big boys and girls and big people. You can deal with 2 languages in one course. You're grown-ups. So yes, arrow functions in JavaScript are very similar to these arrow functions, or lambda expressions as they're called, in Java. They're similar in the sense that what they are doing is defining a new function or method on the fly. Arrow functions in JavaScript really are more like functions. In this case, we call it a method because it is a method of a class, but it's an anonymous inner class, a class that has no name, of which there will only ever be one instance. So it really is more like just a plain old function. It's kind of Java starting from this standpoint of, we're this beautiful object-oriented language where all code has to be inside a class, and then realizing 20 years later, that was a really dumb idea, because sometimes all you need is a simple little function. How can we introduce just little bitty simple little functions into this language that is so bloated where everything has to be an overblown production of a class? We will introduce this syntax for something that looks like a simple little function, but in fact, under the hood, it's still a great big class. It's just a class that only happens to have one method in it, where I can infer, because I know it's a comparator student, I know that this function has to be an implementation of compare. So I can infer the public int part of it. Because it's a comparator student, I can infer that S1 and S2 are F-type student. And I can infer that the thing on the right-hand side is the thing that comes after the return. So in fact, if we go down just a little bit further, here is a comparator for units reversed. I simply say comparator student, units comparator reversed. I say what my two parameters are that are going to be my parameters to my compare method. And I have an arrow, and then I have, this is the value that you should be returning. And I'm just going to compare, I'm going to integer compare the units, and I'm going to multiply by -1 because I want it in reverse order. And indeed, when I run it, we see that using the units comparator, here 23, 56, 75, 123, 178, 198, it's in order by ascending units. Units comparator reversed, it's the reverse order. There it is. Okay, any questions on any of that? All right, let's take it one more step. So let's now make a name comparator. And the first thing we're going to do is we're going to fix our last name comparator and our first name comparator. So what we want to do is we want to make the comparison not depend on uppercase versus lowercase. So one way we can do that is just converting the names to all lowercase or all uppercase, doesn't really matter, before we make the comparison. So we can basically go to a web browser. If I can find Zoom controls, taking up all the room on my screen here. We can go over here and say string Java 11 to bring up the Java doc. Pages like this are called the Java doc. And sometime before the course is over, we will discover how to create Java doc for our own classes. But this is the format of documentation for Java code. And what we want to do is come down here and look through these methods and see if we can find something that does uppercase or lowercase. And sure enough, here we have two uppercase. Also curious to see if there might be a compare. Oh, look at that. Compare to ignore case. That looks like a good handy thing to have. And it looks like it's probably exactly what we want. So we can either convert to uppercase or lowercase, or just use compare to ignore case. Let's just go ahead and use compare to ignore case. So let's jump back into VS Code, and we'll just replace this with compare to ignore case. I'm going to do the same thing over here in student.java with our first name comparator. Then what I'm going to do is I'm going to make another comparator over here. And this comparator student, and let's call this, let me think about this a minute. I think I want to call this roster comparator equals. Now I'm just going to put ... for now. Here's what I want. Compare first by last name, then first name, then perm. That is, the order should be like this. So as you may know, we have Richard Wang in our department, and we have Yuan Fong Wang in our department, and we have, let's see, we have Yusheng, I don't know, I think it's Yusheng Wang, and then we also have William Wang. Now, since the last names are a tie, we use the first name to break the tie, and so it should be Richard first, then actually, believe it or not, I just WX, oh, no, W should come before Y. So it should be like that, yes? That should be the order. But what if there's only one William Wang in our department as faculty, but what if I had two students named William Wang? It could happen. I have had it happen before, that I had two students with exactly the same first name and last name in my class at the same time. In that case, the only way to differentiate is by perm number. And so we want to make sure that if that happens, that these two students always appear in the same order. So we're going to come up with some data like this, maybe. There. Okay, so there's some test data that we could use. So we'll make a data file that has folks in it like that. So let's come over and I'm just going to, actually I can do my data files right in VS Code, just like any other file. So let's, that is not what I want. I want to go back to files. Where did they go? Where did they go? Oh, VS Code, you're confusing me today. There should be one more button up there. How did that button get down there instead of, I don't know. Anyway, are these draggable? Holy crap, they're draggable. Today I learned. All right, so let's go into our data file. There's data folder, I should say. There we go, data folder. And I will make a new file under the data folder, and I'll call this tiebreakers.csv. And I'll paste in these. And we also are going to need units. Some way to do like, I've forgotten what it is. There's some way that since I have that selected, I can just in VS Code, I can with one command change all of that. Unfortunately, I can't remember how it works right now. So we'll do that another time. I need to add units to all of these folks so that the parser will be happy. All right, so there are my, there's my data file. And let's just make sure that that data file is in the right format before we do anything else. I called that tiebreaker. Oh, I guess I didn't save it yet. Why did nothing come out? That's weird. More data tiebreaker. Okay. I am confused as to why. Oh, I get it. They're all saying line with invalid perm ignored. So, oh, and I know what it is. I know what it is. The problem is this space right here. I need to make sure, because it's going to try to convert that into an integer, and that space, it doesn't like that space. Let's go ahead and just take out all the spaces in our CSV, and then I think it will work. So let's try that again. That's what the data file looks like. And then here's what happens when I run. That's what I'm talking about. Okay, so what we want is to write a comparator that will give us our data in the order that we specified. So let's go back to read students. So I believe what we can do is we can basically make a comparator that is a composite comparator. I'm going to make a instance of my last name comparator. So I'm going to say new student last name comparator dot. Comparators have, oh, I need a parentheses on that. They have a method called then comparing, where you can pass in another comparator. So I'm going to do then comparing new student first name comparator dot then comparing. And then I'm going to do, what's our comparator up here? Units, no, not units comparator, the perm comparator. Now I don't actually have a perm comparator. I have the compare to method. So I will have to make a perm comparator. So we can just make one of those on the fly right quick. We can say comparator comparator student perm comparator equals S1, S2, arrow, and I can do S1.getPerm minus S2.getPerm. That could also have been written as, just to review, could also write that as integer.compare S1.getPerm, comma, S2.getPerm. So two equally valid ways of writing that comparator. So then comparing perm comparator. Boom. Now, let's see. It is complaining about student first name comparator, and that's because it is actually student dot first name comparator. And now it's complaining only because I haven't used it yet. So if I want to use it, I need to actually do a sort with it. So let's come down here, students.sort, and we will use our roster comparator, comparator, and we'll say sorted by roster comparator. And let's give it a try. So we need to Maven package. Excuse me. Okay, we have a test failure. What did we do here? Excuse me again. Let's see, what happened to us here? Oh gosh, we have a lot of, we broke something badly. Errors 17. Oh my goodness. Okay, let's just do Maven clean test and see what's going on. What did I break? I broke nothing. So sometimes you just have to do a Maven clean and everything comes back to normal. This was probably a result of me switching branches. When you switch branches, it's a good idea to do a Maven clean. So let's try that again. Let's do Maven clean package. Now everybody's happy again. Let's run this on our tiebreaker data. And do we get folks in the right order? We get all of these Wangs in the right order, when Richard and then William, then Yunfang, then Yushang, and the two Williams came out in the correct order. But were they in that order to begin with? If so, then that's, not very impressive. Let's go into tiebreaker and let's rearrange all of these. So let's just kind of shuffle them around a bit. All right, so now we have this William Wang comes before that one, but in the perm order, this William Wang should come second and that one first. Let this Richard Wang should come first, but he's now at the bottom of the file. And this Yunfang should come actually, I think near the end, not exactly at the end. Yushang should be at the total end, but this is all mixed up now. Let's make sure that when we run it again, there's our original order with Richard at the end, Yunfang at the top. And now we have it, and it is indeed coming out in the correct order with the William Wang 1, 2, 3, 4, 5, 6 first, the William Wang 2, 3, 4, 5, 6, 7 second. All right, victory is sweet. That is how you would make a comparator. And the question came up earlier, which is more often used, comparable or comparators? Here is the beautiful thing about comparators. You can write a comparator for any class you want at any time. As long as you have a way to take two objects and define a comparison on them, you can make a comparator for them and you can sort them. Is that true of comparable? Can you make any class you want comparable? What do you have to do? If a class does not implement comparable, what do you have to do to make it implement comparable? That's a question for you that are here. to answer on the chat. What did we have to do to make student implement comparable? Exactly. We had to define the compare to method. So in order to make a class implement comparable, you have to have access to the source code for that class. And you have to have the ability and the authority to modify that source code. However, even if you don't have the ability or the authority to modify the source code for a Java class, you can still make a comparator for it. As long as you have some basis, as long as there are like getters for some field in the class that you can compare one object with another, you can make a comparator for it. So in that sense, comparators are far more general and far more useful. Comparable is just convenient because you can bake it right into the object itself. Okay, so this basically leads us up to the point where we are ready for the next programming assignment, which I will, now that this material is out there, I'll be releasing that next programming assignment sometime in the next 24 hours. All right, so the rest of lecture, I started to show the next programming assignment, realized that I was actually showing the answer key for the next programming assignment, so I decided to cut that from the recording. Students only saw it very briefly, not enough time to actually get the answers, but if it had been on the video where you could have paused it and saw the solution, then that would have sort of, that would not have been good. So I clipped that. I'm putting this clip in instead to just let you know that even though it seems like the lecture abruptly ended, this is really the end of the today's lecture video. So hope you enjoyed it. If you found yourself very confused by it, there is a link in the announcements to a web page. It's actually on under topics, the topic Java sorting. It goes through the same material but a different set of examples. That may help. And we will be releasing the next Java programming assignment, JPA 04, sometime in the next 24 to 48 hours.